In 2002, Honda debuted a touring bike so advanced, riders said it was built to rule the highways forever. But then the cracks started showing, literally. Was this engineering perfection we'd come to believe, or a ticking time bomb? This is the shocking truth behind Honda's banned 1800cc Gold Wing. In the early 2000s, big touring bikers ruled the highways. Honda was building something revolutionary, the 2002 GL 1800 with an aluminum frame instead of traditional steel. This was airplane technology brought to motorcycles. Engineers called it the flying sofa. When it worked, motorcycle writers said it was like riding a luxury hotel on wheels. But aluminum frames need perfect welding and assembly. One mistake and cracks could appear. During testing in Arizona, a Honda rider's frame started cracking at 75 miles per hour. They kept it quiet, but word leaked out. The question everyone asked, if it happened once, when would it happen again? Honda's marketing team went crazy promoting the new bike. They called it the most advanced touring bike ever built. Motorcycle magazines put it on their covers. Dealers were taking orders faster than they can write them down. The GL 1800 wasn't just a motorcycle, it was a promise of perfect touring wrapped in aluminum and luxury. The numbers were incredible. The bike had a 1832cc flat-six engine. That's huge. It had a reverse gear, which no other bike had. It had a built-in stereo system. The price would have made grown men cry. The special 30th anniversary models cost over $25,000 with all the fancy options. Touring clubs and long-distance riders were going crazy trying to get one. Famous riders wanted to test them. Motorcycle magazines were calling it the bike of the decade before most people had even ridden one on a real trip. But behind all of that excitement, there were warning signs. A secret Honda memo from early 2002 said, "Frame welding is critical for the bike to last. We recommend training dealers before they work on these bikes." But that training never really happened. Honda was in a hurry to beat other companies to market, and being careful took second place to selling bikes fast. The pressure to launch was huge. Other companies were making their own luxury touring bikes. Honda needed to be the first to market to win the touring bike wars, but rushing technology always carries big risks. What Honda put on the market wasn't just a motorcycle, it was a potential disaster waiting to happen. And it didn't take long for that disaster to start showing up. The first signs of trouble showed up just months after the bikes went on sale. But these weren't random problems. They were systematic failures that followed the same pattern over and over. Riders started reporting a terrifying problem, small cracks appearing in aluminium frame welds, specifically where the lower crossmember connected to the side rails. This wasn't just cosmetic damage. These cracks could grow and cause the whole frame to fail. The pattern was always the same and always scary. Owners would notice tiny cracks during routine checks, or worse, they'd feel the bike handling strangely and discover frame damage. While Honda's official records don't show anyone getting hurt from these frame failures, the potential was terrifying. A total frame failure at highway speeds could easily cause a rider to lose control and crash. What made the whole situation worse was how random it seemed. Some owners with lots of miles had no problems, others with almost new bikes found serious cracks. The randomness suggested that something was wrong with how the bikes were being built, or that some dealers were doing the assembly work better than others. The geographic spread was also concerning. Reports were coming in from all over the country: California, Texas, Florida, New York. Everywhere Honda sold these bikes, some owners were finding cracks. This wasn't a problem with one bad dealer or one bad batch of bikes. This was affecting the entire production run. Online forums started filling up with worried owners sharing photos of their cracked frames. The pictures were shocking. What looked like tiny hairline cracks in some photos were actually serious structural damage that could grow into complete frame failure. Honda's first response was to look at each case individually. They often said the failures were caused by extreme riding or not taking care of the bike properly. But as more and more reports came in, the explanation became harder and harder to believe. Honda's initial reaction was exactly what you'd expect from a big corporation. They looked at each broken bike separately. They emphasized that owners needed to maintain their bikes properly. They suggested that the failures happened because people were riding their bikes too hard or not following the maintenance schedule. From Honda's point of view, this made sense. No company wants to admit they have a design problem without being absolutely sure. Honda said that if people assembled the bikes correctly and took care of them, there wouldn't be any problems. They also pointed out that most owners never had any issues at all. But this response made owners and the touring community furious. The evidence kept piling up. Multiple bike mechanics who didn't work for Honda started documenting the same failure patterns. Metal analysis suggested the cracks started from stress points in the welding areas. What hurt Honda's position the most was that failures were happening on bikes that had been properly maintained with full service records. Independent mechanics started posting detailed photos and analysis online. They showed how the cracks always started in the same place and grew in the same pattern. Some mechanics even predicted where cracks would appear on bikes that hadn't failed yet, and they were often right. The touring community was getting organized. Instead of just complaining individually, rider groups started sharing information and data. Online forums became clearinghouses for technical information. By 2003, the situation had grown way beyond individual warranty claims. Touring organizations were collecting data from multiple sources. Internet forums were filled with documented cases, complete with photos and technical analysis. The pattern was undeniable, and Honda was facing a choice: keep denying there was a systematic problem, or admit they had a serious issue that needed fixing. What happened next was unprecedented in motorcycle history. Instead of accepting Honda's explanations, the touring community did something that had never been done before. They organized their own technical investigation. The Gold Wing Road Riders Association led the charge. It started at their national rally when 3 different GL 1800s showed frame cracks during the same weekend. One bike cracked during normal highway riding, another cracked while just moving around a parking lot. Seeing $75,000 worth of dream bikes turned into cracked aluminum was the last straw for the touring community. 5 separate touring clubs did something amazing. They pooled their money and hired their own engineers to analyze the problem. They commissioned independent metal testing. They paid for stress analysis. They treated this like a criminal investigation, and Honda was the prime suspect. What they found was devastating to Honda's position. The data showed a clear picture of systematic engineering failure that Honda could no longer deny. Stress analysis showed critical cracks happening under normal touring loads, not extreme riding. Temperature studies showed heat damage appearing right after bikes came back from Honda warranty work. Vibration analysis revealed specific frequencies that matched exactly where failures were happening. The most damaging evidence was the metallurgy report that the clubs paid for themselves. Independent lab analysis of broken parts showed stress patterns that could only happen from systematic design problems, not from riders abusing their bikes. The welds were failing at predictable stress points that any good engineer should have caught during development. When we showed Honda all this advice, they didn't send engineers to talk about solutions, said one club president. They sent lawyers to threaten us with lawsuits if we went public. That's when we knew this wasn't about engineering anymore. This was about the company trying to protect itself. The touring organizations fought back by threatening to boycott Honda completely. The Wing Ding rally organizers publicly said they might ban Honda from their events. The American Motorcyclists Association said they were looking at other options for their touring bike recommendations. The potential loss of touring community support, worth millions in free advertising, finally got Honda's attention. But the riders weren't finished. They started working with independent mechanics in motorcycle organizations around the world. What began as isolated complaints in America became a coordinated global investigation. Social media became a battlefield. Professional mechanics posted detailed teardown videos that went viral. Forums exploded with documented cases from 6 continents. The hashtag Honda Recall started trending globally as owners shared photos of destroyed frames and repair bills that cost thousands of dollars. YouTube channels dedicated to GL 1800 failures appeared overnight. Mechanics in Germany, Australia, and the United States started sharing identical failure patterns. Touring organizations began warning riders about the GL 1800 reliability. Insurance companies quietly started flagging early GL 1800s as high-risk motorcycles. The most damaging revelation came from former Honda factory workers who broke their employment contracts to tell the truth. "We called it the highway time bomb during development," said one anonymous former employee. Management said, "Most touring riders won't stress it that hard." They were completely wrong. The rebellion had become a full-scale war, and Honda was losing badly. With pressure coming from every direction, something had to give. By late 2003, Honda was in an impossible position. The evidence from multiple sources, owners, independent mechanics, and touring organizations, painted a clear picture of systematic frame welding problems affecting specific groups of 2002 and 2003 GL 1800 motorcycles. Honda's announcement was carefully written but decisive. They issued a safety recall affecting approximately 18,000 units in the US alone. Per NHTSA records, the recall notice described the problem as a need to add additional TIG welding to the frame where the lower crossmember meets the side rails, because under certain conditions, some existing reinforced welds can crack or fail. The recall was massive and expensive. Honda immediately stopped selling all affected bikes until repairs were completed. They required dealers to have access to qualified aluminum welders. If dealers didn't have the right skills, Honda helped them find qualified professionals. The company provided detailed repair kits and step-by-step procedures to make sure every repair was done correctly. What made this recall particularly significant was how complete it was. Rather than just patching the problem, Honda essentially reinforced the entire lower frame structure. This suggested the company had figured out exactly what was wrong and was implementing a real solution, not just a quick fix. The recall notice was very clear about the seriousness. Any sales of an affected motorcycle after receiving this notice and prior to repair is a violation of federal law. Honda was taking no chances with legal liability. The repair process was intensive and expensive. Each bike had to be partially disassembled to access the frame welds. The additional welding had to be done by certified professionals using specific procedures. The whole process took weeks per bike and cost Honda millions of dollars. But the recall worked. Owners who got their bikes repaired reported that the handling was actually better than before. The additional welding made the frames stronger and more reliable. Many owners said their bikes felt more solid and confident inspiring after the recall work was completed. From a corporate perspective, Honda's handling of the recall was actually very good once they acknowledged the problem. They provided comprehensive repairs, used qualified technicians, and communicated clearly with dealers and owners. However, Honda never issued a public apology, opting instead for technical service bulletins, a common industry approach to avoid reputational damage. This strategy allows manufacturers to fix problems without creating bigger public relation issues or admitting fault that could be used against them in lawsuits. The recall was ultimately successful. The affected bikes were properly repaired, and no serious injuries were documented as a result of the frame's problems. But the experience taught Honda important lessons about rushing new technology to market. What's interesting is how this experience appears to have changed Honda's approach to new technology. Modern gold-wing frames show clear evidence of lessons learned from the 2002 to 2003 problems. The welding procedures are much more robust. Dealer training is more comprehensive. Quality control has additional checkpoints that didn't exist before. The 2002 to 2003 GL 1800 frame recall represents a fascinating case study on what happens when innovation meets manufacturing reality. Honda had genuinely revolutionary technology, aluminium frame construction that offered significant advantages in weight and performance, but the complexity of that technology created manufacturing challenges that weren't fully anticipated. The GL 1800 story raises important questions about how the motorcycle industry develops and tests new technology. Should companies release revolutionary technology knowing there might be unforeseen problems? How much testing is enough before bringing new concepts to market? Some industry observers speculate that Honda's current frame technology still uses aluminum principles, but with all the manufacturing problems solved. The handling characteristics of modern Goldwings suggest sophisticated engineering that builds on the 2002 innovations while avoiding the problems. The basic idea wasn't wrong, suggests one former Honda engineer who agreed to speak anonymously. It was the execution and quality control that needed work. Modern frames use similar principles, but with much better manufacturing consistency and quality control. This raises an interesting question about the nature of innovation in the motorcycle industry. Early adopters of groundbreaking tech often face higher risks. While there's no evidence Honda intended this, the pattern suggests that being the first to market with revolutionary technology carries risks that affect both manufacturers and consumers. The broader motorcycle industry learned important lessons from Honda's experience. Other manufacturers watched carefully to see how Honda handled the situation. The recall became a case study in corporate crisis management that influenced how other companies approach similar problems. From a rider's perspective, the story offers important lessons about being early adopters of new technology. Revolutionary advances often come with higher risks, and buyers should factor this into their purchasing decisions. The most advanced technology isn't always the most reliable technology, especially in the first few years of production. What's fascinating about the GL 1800 story is how it appears to have influenced Honda's entire approach to motorcycle development. The company became much more conservative about releasing new frame technology. They invested heavily in testing and quality control. They improved dealer training programs, but the story also had broader implications for the motorcycle industry. Other manufacturers learned from Honda's mistakes. They saw how quickly a reputation could be damaged by rushing new technology to market. They witnessed how organized consumer advocacy could force corporate accountability. The internet played a crucial role in the GL 1800 story. Without online forums and social media, individual owners might never have realized their problems were part of a larger pattern. The ability to share photos, technical analysis, and coordinate investigations gave consumers power they never had before. This was probably one of the first major automotive recalls that was significantly influenced by internet-based consumer advocacy. The traditional model of isolated customer complaints being handled individually was completely disrupted by coordinated online investigation and documentation. The recall also highlighted the importance of independent technical analysis. The touring community's decision to commission their own engineering studies and metallurgy reports provided evidence that Honda couldn't dismiss or ignore. This approach has since been used in other customer advocacy situations. From a technical perspective, the GL 1800 frame problems illustrated the challenges of scaling up new manufacturing techniques. What works perfectly in a laboratory or prototype setting may face unexpected challenges when applied to mass production. The precision required for aluminum frame welding was difficult to maintain across thousands of units and multiple production facilities. The 2002-2003 GL 1800 frame recall story has a mostly positive ending. The recalls were successful. The underlying technology was sound, and Honda's learned experience resulted in much more reliable current models. Modern Goldwings benefit from the hard-won knowledge gained during this challenging period. Today's Goldwing owners enjoy bikes that incorporate all the lessons learned from the early aluminum frame problems. The welding is more consistent, the quality control is more rigorous, the dealer training is more comprehensive. In many ways, current Goldwing owners are the beneficiaries of the problems experienced by early adopters. The recall also established important precedents of how manufacturers should handle systematic quality problems. Honda's eventual comprehensive response became a model for how to properly address widespread manufacturing defects. The key lessons were: acknowledge the problem quickly, implement comprehensive solutions, and communicate clearly with affected customers. For the broader motorcycle industry, the GL 1800 story demonstrated the importance of adequate testing before bringing revolutionary technology to market. It showed how quickly consumer advocacy could organize and influence corporate behavior. It highlighted the role of internet communication in coordinating consumer response to manufacturer problems. The story also illustrates the challenges facing motorcycle manufacturers as they try to innovate while maintaining reliability. The pressure to introduce new technology quickly must be balanced against the need for thorough testing and quality control. The GL 1800 experience showed what happens when that balance tips too far towards innovation at the expense of reliability. The GL 1800 frame recall raises uncomfortable questions about the balance between innovation and reliability in motorcycle manufacturing. Revolutionary technology often requires years of real-world testing to identify and solve unexpected problems, but market pressures push manufacturers to release new technology as quickly as possible. This creates a tension between the desire for cutting-edge performance and the need for proven reliability. Early adopters of new technology essentially become real-world testers, experiencing both the benefits and the risks of being first to market with revolutionary features. The motorcycle industry has generally handled this tension by being conservative with safety-critical components like frames and brakes, while being more aggressive with performance and comfort features. But the GL 1800 story shows what happens when revolutionary technology is applied to critical structural components without adequate real-world testing. Honda's experience also highlights the importance of manufacturing quality control when dealing with complex new technologies. The precision required for aluminum frame welding was much higher than traditional steel frame construction. This required different training, different procedures, and different quality control measures. The company's initial resistance to acknowledging systematic problems created more controversy than the technical problems themselves. In contrast, their eventual comprehensive recall response was generally praised by affected owners. This suggests that corporate response to emerging problems is often more important than the technical problems themselves. The GL 1800 frame recall story offers several important lessons for modern motorcycle buyers. First, revolutionary technology often comes with higher risks during the initial production years. Buyers who want the latest innovation should understand they're potentially trading proven reliability for cutting-edge features. Second, the importance of community knowledge sharing was crucial in this case. Individual owners might have been dismissed, but coordinated documentation and analysis forced manufacturer accountability. Online forums and owners groups serve an important watchdog function that protects all consumers. Third, Honda's eventual response was comprehensive and effective. This suggests that even when problems occur, manufacturer commitment to proper solution matters enormously for long-term customer satisfaction. For current Goldwing owners, this story is ultimately positive. The recalls were successful, the underlying technology was sound, and Honda's learned experience has resulted in more reliable current models. Modern Goldwings benefit from this hard-won knowledge gained during this challenging period. The technology lived on in refined form, and thousands of owners continued to enjoy trouble-free touring for hundreds of thousands of miles. Many of the recalled bikes are still on the road today, running perfectly after their frame reinforcement. But the story serves as a reminder that in the world of advanced motorcycles, the relationship between innovation and reliability is always evolving. The most sophisticated engineering is only as good as the manufacturing processes and quality control that bring it to life. Let's debate this in the comments. Are you an early adopter who accepts the risks of new technologies? Or do you prefer until others have worked out the problems first? Have you ever owned a first-year model of a revolutionary motorcycle? What was your experience? And if you want more stories about the fascinating intersection of motorcycle innovation and real-world reliability, hit that subscribe button and ring the notification bell.